concentration term we are going to consider in today's class is mole fraction. The symbol for mole fraction is X. Okay? Let's start with an assumption. Let's assume that we have A and B and C reacting. And let's also assume that the number of mole of A is regarded as what? Na. And the number of mole of B is regarded as what? Mb. And that of C is Nc. Right? This is the number of mole for this, number of mole for this, number of mole for this. Now, if I want to find the mole fraction of each of these, just like the way we have, if I have a class, let's say in a class, there are 100 students and 20 are boys, the rest are girls. Out of 100 students, 20 are boys, the rest are girls. If I ask you, what is the fraction of the boys in the class? You simply say 20 over 100, right? Which is roughly 1 over 5. Okay? If I ask you for the fraction of the girls, you say 80 over 100. You simplify. You have, whatever you have is the fraction, right? Simplest form is the fraction. Now, that is the same way we do mole fraction. Now, let's say we have a mixture of different compounds with a specific mole. Let's say the number of mole for this is A, this is B, this is C. If you are asked to find the mole fraction, watch. If I write X and I put subscript A, this means the mole fraction of this A inside this thing. What should it be? The mole fraction of A will be number of moles of the A divided by number of mole of A plus number of mole of B plus number of mole of what? C. If you are asked to get the mole fraction of B, the mole fraction of B is number of mole of that B all over number of mole of A plus number of mole of B plus number of mole of C. If I want to get the mole fraction of C, it's the same thing. Number of mole of C over number of mole of A plus number of mole of B plus number of mole of C. Recall, this mole fraction, we can say that this Na, if you sum all together, if you sum all of them together, we can call it N total. That is, this plus this plus this can be equal to N total, where this N total is total number of moles. Right? If the N total is total number of moles, this plus this plus this is equal to this. We can also say that the mole fraction of A is equal to number of mole of A over N total. We can also say that mole fraction of B is number of mole of B over N total. While the mole fraction of C is number of mole of C over N total. So look at this expression, it's the same thing. Everything here, this is the same thing as this. This is the same thing as this. While this is the same thing as this. So both are the same. So the mole fraction is simply the mole of the one you are looking for over the total number of moles. So take note, mole fraction does not have any units. Mole fraction is dimensionless. Mole fraction is unitless. Why? Because the mole will cancel the mole down, so no dimension, no unit for mole. So when you are done calculating your mole fraction, simply leave your answer like that without any units. Okay? So mole fraction is simply the ratio between two moles. Now, take a look at the question on the board. Determine the mole fraction of sodium chloride in a solution containing 20.35 grams of sodium chloride in 600 centimeter cube of water. Okay? In 600 centimeter. Now, look at the question very well. Mole fraction of this 1. We are looking for the mole fraction of sodium chloride. Mole fraction of the sodium chloride should be number of mole of sodium chloride, if I'm not mistaken, divided by number of mole of sodium chloride plus number of mole of what? Water, because we only have two things in the solution. That is sodium chloride and what? Water. Okay? How do we get number of mole of sodium chloride? Number of mole of sodium chloride is equal to mass of the sodium chloride over the molar mass of sodium chloride. Okay? At your age, you should be able to know how to get the molar mass of sodium chloride. Sodium chloride, which is this, is sodium chloride is equal to 23 plus 35.5. That should give us 58.5 gram per mole. The molar mass. The mass was given as 20.35. So number of mole of sodium chloride will be equal to 20.35 divided by 58.3.5. So if you divide 20.35 by 58.5, 20.35 divided by 58.5. So what you will get here is 0.348. 0.348 moles, right? That is the number of moles for sodium chloride. Okay, but water, what was given is the volume of water, right? We know that density of water is 1.0 gram per cm cube, right? So from the density is equal to mass over volume. So therefore, the mass will be equal to density times volume, right? Which is equal to, density is 1.0 gram per cm cube times the volume 600 centimeter cube. So cm cube cancels cm cube. So mass becomes 600 grams. Okay? Mass of water, please. Mass of water. Remember, mass of water. H2O. So the next thing now is to get the what? Mole of water, right? So to get the mole of water becomes 600 over 18. How did I get 18, class? 18 is the molar mass of what? Water. 1 times 2 plus 16, 18. So 600 divided by 18, you have equal to 33.33 mole, right? So watch, we have gotten the two things we need. We need this, we need this. So we can plug it inside here and get this. So the next step is to quickly just plug in these values. This one is for this, so I can just clean this, replace it with what? 0.348. Then I also repeat this, 0.348. Then for water will be plus 33.33, right? So I will quickly what? Add these two and divide with this. So we have this plus 0.348. So we equal to this. So we have that mole fraction of sodium chloride will be equal to 0.348 divided by 33.681. So the mole fraction becomes 0.01. That's the mole fraction. So the mole fraction becomes 0.01. Take note, mole fraction does not have any unit. So once you divide this, whatever you have here is the final answer.